Okay, so we're going to cover the operating profile later on, but here it says from C state 0 to 5 meters for all the speed, right? Because you have 5 knots, 15 knots, 25 knots, and all the headings, everything is 1. Add everything is 100%. In one C state, it doesn't matter what speed you use, the total probability should be 1. A different C state, if you run into that, to add them, it should be 1. Okay, so sometimes you say, well, I don't want the high C state, those zeros, right? Here's 10 to 60 meters. I'm not running 25 knots. So, but then that means in the high C state, you will have a high probability in the low speed. So we have, if you expose 1 hour or 100 hours in the high C state, you have 76% in that speed and that heading of the 100 hours. And the others very small, you don't operate in the 25 knots. So that's, user can define this. You say, okay, I don't really run this. I just say 0. I'm not running this. You just prohibit. You do not run that. You say modify that. So now you have the probability changes. User can modify your operating profile. Okay. And now when you run the fatigue, you can change to how to define the operating profile. We have one session and explain how you using this. But after you define it, you can change it. So okay, I don't run this at BIMC. I'm not running that. So you can modify that. So then that's a new operating profile. Let's say I want to have 15 years using that operating profile, right? Okay, and the same, I need to go to here. I already select that. So you're using 15 years and the combatant operating profile, you add that. So you have 2 total, you have 45 years. 30 years, you're using the equal probability. And 15 years, you're using combatant. And you may have another. You can keep doing that. So this is together as a 45 years fatigue life. So I say, okay, modify that. Now you can review this. This is 2 scenarios. First scenario is first 30 years equal probability. The next 15 years are using this combatant. Okay, so now we run the fatigue. It's going to using 2 operating profile. Okay, first is typical. So you run 1, you run 2. So now this is a 45 years fatigue life. So it's failed. So when you have 30 years in equal probability and 15 years in combatant probabilities, then the exposure time will be different because your operating profile is different. We run twice. You add them together. So above that, that's the first scenario. Okay, the maximum damage ratio is 0.84 for 30 years equal probability. Then we run another scenario, that's another 15 years, using this, or you can using a different S&N curve. And this is using the combatant operating profile. Then we calculate the fatigue for that. So the first is running this fatigue, the second is running the second fatigue. Then it's added together, superposition. Okay, but that fatigue is based on the new operating profile. The second operating profile is based on this. Okay, using the same S&N curve, same locations, but different years. Then the minus rule is based on a new operating profile, and because that's with different probability, you have different exposure time. So the N, the number of cycles, you're going to see different. If you have more time in a C state, you have more cycles of stress change. And then you have incurred more damages. So mathematics is not difficult. It's just the bookkeeping. You have to carefully bookkeeping for that element, how many cycles you get run into that. Because yeah, as you can see, we have a lot of C states. So the C states. So basically, we run this C state. We just walk through every C state and then find out how many times you expose in that C state, how many cycles SN curve, how many stress cycles you're going to have for that stress level. Then just keep doing this until you calculate everything for the fatigue damage.